Hello, good evening to all. My name is Parameshwaran KV. I am from Chimya Vidyalaya, Kolangur, Palakkad. My subject is mathematics. Today we are going to learn one of the important chapter in class 10 mathematics, that is application of trigonometry. This chapter we will learn so many trigonometrical applications which is applied in our daily life. So let us go into the video. Hello children, good evening to all. So today we are going to learn about the chapter application of trigonometry. So before going to the chapter, we should know what is trigonometry. We should have an idea about what is trigonometry. Only then we can learn what is application of trigonometry. So already we have got an idea about the chapter trigonometry, and we have learned so many different types of trigonometric ratios in that chapter, right? So this chapter is all about how we can apply that concept of trigonometric ratios in our real life in various situations. That is what we are going to learn in this chapter, right? And as you all know that in trigonometry there is a peculiarity for that. That is, we will be only discussing with the concept of right triangles. Trigonometry is only applicable for the concept of right triangles. So how we can apply these concepts in right triangles, and how we can find the height and distances of these triangles, that is what we are going to discuss now. So this is the heading of the chapter, application of trigonometry. Let me directly go into the concept. So, as I have told earlier, these are some figures that we don't know what is the height of the given mountain or the tree, right? So, to find out that, we can apply the concept of applications of trigonometry. Okay. So, this is the mountain that we can see the height is not given here, and this is also a tree in which the height is not given. So, how we can find these heights and distances? That is the main question in this chapter. So, let us see. So, before moving to the chapter, let me introduce the basic terminologies of this chapter. For each and every chapter, there are certain things that we have to learn. Only then we can apply it properly. So, in this chapter, application of trigonometry, there are mainly three things that we need to learn, right? So, the main terminologies of these chapters are horizontal line, angle of elevation, and angle of depression. So these are the three basic terminologies. Before that, there is also one more concept that we have to learn. Suppose we are observing an object from a distance, right? There is an imaginary line which starts from our eye and which falls on that object, and that imaginary line is called line of sight. That imaginary line is called line of sight. So from that line of sight, we can see that object, right? And the next concept is horizontal line. So what is horizontal line, right? And how it can be formed? Let me explain in the next slide. Yes, horizontal line. So in this horizontal line, as you can see, dear children, this is the starting point of this observer, right? So from this point, the observer sees the object. So the line which is drawn parallel to the ground that you can see here, this is called horizontal line. Suppose children, if I am just seeing a person in front of me, I will be like this, right? So there will be an imaginary line that is created from the part of the observer and from me. So that imaginary line is called line of sight. And more than that, there will be an horizontal line which is drawn parallel to the ground level. That is also an imaginary line. So whenever I am viewing an object or I am seeing an object above that horizontal line, definitely there will be an angle which is formed in between the horizontal line and the line of sight, right? So that is this angle. This angle is called angle of elevation. So this horizontal line is just a imaginary parallel line which is parallel to the ground level, and with the basics of this line we are finding the angles. Okay, so this horizontal line can be also considered as the baseline in application of trigonometry. So whenever I am observing an object which is above the horizontal line, so there will be a line of sight. So a line of sight is formed and also horizontal line is formed. So what is the angle formed in between the horizontal line and the line of sight? That is most important, right? And that angle is called angle of elevation. So the first terminology that we are learning in this chapter is horizontal line. Before that, line of sight is also there, but more than that, horizontal line is most important. And above the horizontal line, a specific angle is formed, and that angle is called angle of elevation, right? So that elevated angle, right? When we are observing an object above the horizontal line, definitely our view will be like in the upright position, right? So that angle which is formed here is called angle of elevation. Okay, I hope it is clear. So let me show you some examples related to that. This is a perfect example for that. A man who is viewing an object, who is observing an object, and a line of sight is created here, right? And in the same way, we can see an angle as formed here, which is an acute angle. So angle of elevation has happened here. So this OB is the horizontal, right? I hope you can see here, and we can also see the view, right? Starting from the baseline. So this OB and OA, and this is the angle of elevation. So how we can define angle of elevation? Angle of elevation is the angle which is formed just above the horizontal line. Okay, so that is all about application of trigonometry, the first two terminologies. Okay, I hope you understood. So let me go to the next one. The next terminology is somewhat similar to angle of elevation, but there is a change in that. That is, when the angle is formed below the horizontal line, there is another name for that. That is called angle of depression. So whenever the observer is observing an object below the horizontal line, there will be also an angle formed like this. Suppose assume that this is the imaginary horizontal line and the man is observing down. This is the place of object. So what happens here? We are having a new angle, that is called angle of depression, right? That is called angle of depression, and this line is called line of sight. I hope you got that. So this is the main three concepts that we have to understand in this chapter. Only then we can solve the problems correctly. Okay. So first terminology is horizontal line. Second one is angle of elevation, and the third one is angle of depression. Okay, so let us do some problems. Before that, let me show you some more slides which will give you a clear idea regarding the difference in the concept of angle of elevation and angle of depression. Because before going to the problem, we should have a clear basic idea of what is angle of elevation, what is angle of depression. Only then we will be able to catch the problem properly, right? So let me go to that. Yes, this is another example of angle of depression. As you can see that the angle of depression which is formed on below the horizontal line. This parallel line, the horizontal line will be always parallel to the ground level. There is a ground level in which we are standing, right? So below the ground level, that has to be the horizontal line will be always parallel to the ground level. Okay, that is what we can see from here. So angle of depression is formed here, and this is also an example. A bird observing a prey from the branch of a tree to the ground level. So we can see an angle of depression which is formed here, and a horizontal line and a line of sight. So these are the things that we have to learn in this chapter. So let me start with the problem now. And before that, let me show you one more slide. Yes. So what we can see from this slide, a man is observing a plane and a dog both on a the same time. So what we can find? An angle of elevation is formed here, and angle of depression is also formed here. And this is the horizontal line, right? So angle of elevation is always above the horizontal line. Angle of depression is always below the horizontal line. Similarly, a boy who is playing football in the ground observes a building which is at a certain height. At the same time, he is also observing a football, right? So both angle of elevation and angle of depression is happening here. Now, yes. So let us start with this problem. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees within it. The distance between the foot of the tree to the point where the top touches the ground is 8 meters. Find the height of the tree. So what has happened here is that due to a sudden storm, a tree has broken and the top of the tree is touching the ground level of the tree. So what is happening here? We can see a figure here which is given. So that tree is fallen and it is touching the ground, right? So there is a specific angle which is formed in between the tree and the ground level, and that angle is given as 30 degrees from the question itself. So 30 degrees has been marked here. Then what is the next thing? The distance from the foot of the tree to the top of the tree. Now the top is touching the ground, right? So that distance is given as 8 meters. So if this is what we can find from the question, that is the given things from the question. So we need to find the total height of the tree. So logically, when we think about this question to find out the answer, what we will do? We have to find the total height of the tree. So there is a part which is standing perpendicular, and also there is a part which is fallen down, right? So from this figure, what we can find is that the total height of the tree can be found by adding both the parts, right? Both the parts of the figure. So here, let us start like this. Let the broken part of the tree be AC. So here, this broken part can be considered as AC. AC can be taken as the broken part. It is given that distance between the foot of the tree B and the point C is 8 meters. So distance between the foot of the tree and point C is 8 meters. So that also we can mention here. So BC equal to 8 meters, right? So also broken parts of the tree makes an angle 30 degrees with the ground. This is most important. So we are mentioning an angle in this step, which is given in the question. So this 30 degree can be taken as the angle of elevation, right? So this is 30 degree angle which is formed here. So the broken parts of the tree makes an angle 30 degree with the ground. So with the ground level, there is an angle which is formed 30 degree. So this is what we can see from this figure. Okay, so let us move ahead. I hope you got that. So a tree which has fallen down, making an angle of 30 degree with the ground, and which is at a distance of 8 meters from the foot of the tree, right? So that is what we can find from this question. So let me move ahead. We need to find the height of the tree. As I have already told that the height of the tree, the total height of the tree will be the height of the broken part plus height of the remaining tree. So height of the tree is equal to AB plus AC. So now I have drawn a right angle triangle with the help of the question. So AB and BC, right? BC is 8 meters and this angle is 30 degrees. So height of the tree is AB plus AC. So as you know that the angle formed with the foot of the tree and the ground level will be always 90 degrees. Not only in this case, in all the cases such as building, tower, poles, there are so many examples in application of trigonometry. So in all these cases, we can find that the angle formed with the foot of the tree will be always, in this case it is foot of the tree, and in all other cases it will be 90 degree, but because it is standing like this, right? So the angle perfect will be 90 degree. So this is an example of right angle triangle, and we can definitely apply trigonometric applications. So in right triangle ABC, First, we are finding the cos angle of this right angle triangle. Cos 30 equal to 8p. That is cos 30. That is what we need to find from this figure. So cos 30 equal to. Let's find cos 30 now. Cos 30 angle. So cos C, as you know that from the chapter trigonometry we have learned that cos 30 equal to adjacent side by hypotenuse. So here BC is the adjacent side and AC is the hypotenuse. So 8 by AC. Cos 30 equal to 8 by AC. So what is cos 30? It is root 3 by 2, as you know. So 8 by AC. Now cos 30, the value has to be always remembered, not only cos 30 but also for every trigonometric ratios along with the specific angles such as 0, 30, 45 degree, 60 degree, 90 degree. For all these specific angles, there are certain values which should not be forgotten at any time because it is very useful and it should be applied in this type of questions. So everyone has to learn it very correctly without any mistake. So cos 30 root 3 by 2 equal to 8 by AC. So how we can find AC? AC equal to 8 into 2 by root 3. AC equal to 8 into 2 by root 3. So but just we have found out the reciprocal of root 3 by 2 and we have multiplied it with the number 8. So AC equal to 8 into 2 by root 3. So the answer is 8 into 2, 16, 16 by root 3. So as you know that finally we have found out the value of AC, that is 16 by root 3. So now this is 16 by root 3. Let us go to the value of AB. So why we are finding out the value of AB? Because only after finding out the value of AB we can add AB and AC. So AB plus AC will give you the total length of the tree. So now we have only found out the value of AC. Let us find out the value of AB. Yes. So in right angle triangle ABC, now we are finding out the value of sine. At first we have found out the value of cos. Now we are finding out the value for sine. So sine C equal to, as you know that sine is opposite side by hypotenuse. So from this figure of a right angle triangle, 30, that is sine 30 equal to AB by AC, opposite side by hypotenuse. So what is the opposite side? It is AB. And what is the hypotenuse? It is AC. So AB by AC. How we can find AB by AC? Because AB, as you know, sine 30 is 1 by 2. There are so many values, right? So that we should remember. So here, in this case of sine 30, we are taking the value as 1 by 2. 1 by 2 equal to AB by AC, AB by 16 by root 3. So when we are cross multiplying it, what will happen? AB equal to root 3 by 16 into AB, right? So 1 by 2 equal to root 3 by 16 into AB. Sine 30 equal to 1 by 2 equal to root 3 by 16 into AB, right? So let us find out the value of AB now. 1 by 2 into root 3 by 16 will now transpose into 16 by root 3. So it is 16 by 2 root 3. 16 by 2 root 3 equal to AB, and AB can be taken as 16 by 2 root 3 now. And as you know that if there are numbers like this which are multiples, right? 16 is a multiple of 2. So let us cancel it. So the answer will be 8 by root 3. So finally what we are getting? We are getting the value of 8 by root 3. So finally we have reached the solution, and this is the final step for this. Height of the tree equal to AC plus AB. So 16 by root 3 plus 8 by root 3. First we have found that the value is 16 by root 3 and we are now finding that is 8 by root 3. So 24 by root 3 is the final answer that we can get. Multiply root 3 in numerator and denominator. Now what we are going to do? We are just going to multiply the value in numerator and denominator. See carefully, this is 24 by root 3 into root 3 by root 3 into root 3 by root 3. this is the process of rationalization that we have learned in class 9. So how to convert an irrational number in the denominator into rational one, that is what we are doing here. So 24 by root 3 into root 3 by root 3, the answer is 24 into root 3 by 3. And finally, after cancellation, we are successfully finding the answer as 8 root 3. So the answer for the question of broken tree is 8 by root 3. After cancellation and adding of the sides, especially the base part and the broken part of the tree, we are able to find out the answer as 8 by root 3. So I hope it is clear, right? Right, children? Yes. So let me go to the next slide now. So we will be dealing with some more problems based on application of trigonometry, just to make the concept and how we can apply that concept in problems. That is what we are discussing here. So let us go to the next problem. The angle of elevation of a top of a tower from a point on the ground, which is 30 meters away from the foot of the tower, is 30 degrees. So starting with the question itself, we can frame an rough figure in our mind, right? We can also draw it. So the angle of elevation of the top of a tower from a point on the ground. So there is a point on the ground, as you can see, and we are observing the topmost position of a tower. So what we can see is that definitely there will be an angle which is formed here, that is 30 degree. So angle is 30 degree and the base part is 30 meter, right? So this is the perpendicular height. So we now our job is to find the height of the tower. There will be definitely a height for the tower. So we have to find the height of the tower appropriately. So how we can find that? Let us see. Let the tower be AB. So to identify the tower easily, we are taking the height of the tower as AB. So that point be C, right? So that point from the ground in which the observer observes the top of the tower, let it be C. So the angle of elevation definitely will be an angle of elevation. As I have already told, when it is above the horizontal line, there will be an imaginary line which is parallel to the ground level when we are observing an object or any specific position in a certain height. So that position, when we are observing at that time, definitely there will be an angle formed with the eye and the horizontal line, right? So that angle is 30 degree. Now, angle of elevation is here. Angle AC is equal to 30 degree. Since tower is vertical, right? Tower will be always vertical, as I have told before. Tower, building, pole, so many examples are there. So this 30 degree we have taken. So and this 30 degree is angle of elevation. This is 90 degree. So let me go ahead. I hope this one is clear. So we need to find the height of the tower. So height of the tower is, how we can find tan 30. How we are directly applying the concept of trigonometric ratios tan. So tan 30 is equal to AB by BC. Tan 30 is equal to AB by BC. So the height of the tower is not given. That is the thing that we have to find out from this question. So tan 30 equal to AB by BC. Tan 30, the value is 1 by root 3. 1 by root 3 equal to AB by 30. How it has become 30? That BC. Because it is given in the question. The distance from the observer to the foot of the tower is 30 meters. So 30 by root 3 equal to AB. That is what we can find, because after cross multiplying we are able to find out the exact value of 30 by root 3. And after finding 30 by root 3, definitely if there is any irrational number in the denominator, we have to rationalize it. So this root 3 can be rationalized, and 30 by root 3 into root 3 by root 3, and the answer is 30 root 3 by 3. So finally we will be getting 10 root 3. That will be the answer. So hence the height of the tower AB equal to 10 root 3 meter. Okay. So that is what we can find. So 10 root 3 meter is the answer, and this is the height of the tower. So what we have done in the question is simply applying the concept of trigonometric ratios with the heights and distances. This kind of situation may happen in our life also, right? So this 30 meter is given here. Directly I have applied the tan ratio and we have found out the answer. So this is one of the concept. And let me move ahead. So let us consider the next question. The angle of elevation of a cloud from a point 60 meter above a lake is 30 degree and the angle of depression of the reflection of the cloud in the lake is 60 degree. Find the height of the cloud. One of the important questions in the concept of application of trigonometry. So in this question, a man who is standing 60 meter above from the ground level is observing a cloud at an angle of elevation 30 degree. So definitely the man will be standing like this. So from this horizontal line, when the man observes the cloud, what will happen? There will be an angle of elevation of 30 degree. And the same man observes the reflection of the cloud which is below the water level. So that angle of depression is given separately, that is 60 degree. So in this question, we need to find the height of the cloud from the ground to the point of cloud. Okay, so let us see how we can find this. So let me, before starting it, let me give you a basic idea of the different types of mediums that we are going to handle here. So in these type of questions, we will be having two different mediums. That is, the medium which is above the water level, it is called air medium, and the medium which is below the water level, that is water medium. So in this air medium, water medium, there is a connection between that. The distance of the cloud from the surface of the water to the cloud is equal to the distance of the distance from the water level below the reflection. Let me explain it again. So the distance from the water level to the cloud will be directly equal to the distance from the water level to the point of reflection below the water level. So these two air mediums will be equally balanced such that we can find both the distance are equal. So let me go to the concept of trigonometry now. So this distance, that is the distance from the observer's eye, that is that parallel distance, this OA can be taken as h. So from this h, how we can create, we need to find the total length of AB, that is our job. So let me find. So yes, first we are focusing on the 30 degree angle of elevation. So first tan 30, I am taking it directly. AO by OD equal to H by OD. So H is OA, so H by OD. So AO by OD equal to H by OD, that is H by the base distance, that is OD. Here in this case, OD will be equal to CB, and this OD and CB are both equal to the ground level distance, that is the water level, that is depth of the water level distance. Okay, so let me move ahead. So in this question, tan 30 equal to AO by OD equal to H by OD. So H equal to OD by root 3. H equal to OD by root 3. As you know that the tan trigonometric ratio, we will be taking opposite side by adjacent side. So AO by OD. AO is taken as a variable, that is H. So H by OD. So H by OD, and from that we can separate H as OD. We can separate H as OD by root 3, and again we can find the value of OD as root 3H. So this is the first thing that we are finding, and we can place it here, and we will be using it in the next step. So OD equal to root 3H. I hope it is clear now, right? And now let me go to this concept of 60 degree. So in this concept of 60 degree, before moving to that, let me explain this. So what we can see from this figure, a cat which is observing a parrot at a certain angle of elevation, right? So when the cat observes the parrot which is caged, it is a caged parrot, we can see that it is angle of elevation because it is above the horizontal line. Let us go to the case of a parrot. When the parrot observes the cat, what is happening here? There happens an angle of depression. So the angle is below the horizontal. So that's why it is called angle of depression. And there forms a line of sight which is forming in between the observer of the observer side, that is from the cap to the parrot. Okay. So what we can find a particular thing from this fact is that this angle of elevation is happened when the cat is observing parrot, and angle of depression is happened when the parrot is observing cat. So there are two horizontal lines which are drawn parallel to each other. They are imaginary lines. So when the two parallel lines are cut by a transversal, let us consider this line of sight as the transversal. So what is happening here? Angle of depression is equal to angle of elevation. Why? Because it is a concept of alternate interior angles. As you can see, it is very clear because Z shape is formed here. So angle of depression and angle of elevation, right? So that is what we can see, and they are equal to one angle. Okay. So this is the concept of angle of depression equal to angle of elevation. I hope it is clear. So when we are applying this same concept in our cloud question, what is happening here is that angle of depression is formed, and you can see the exact Z shape here, and this will be also 60 degree, right? The angle which is formed with the depth of the water level, that is the reflection, will be also 60 degree. So 60 degree here, 60 degree here. Now what we have to find? We have to find this level, right? So finally we have to find the height of the cloud from the ground level. So here what happens is that, let us assume that this is a right angle triangle. We are assuming it as a right angle triangle, and from this we can find out the height of the cloud from the ground level exactly, right? So let us move into that. So when we consider this length, as I have already told you that the air medium and water medium will be equally balanced in the case of these kind of cloud crystals. So here that length from ground level to the cloud and from the ground level to the reflection, right? That is the water, the beginning of the surface of the water to the reflection will be equal. So this is 60 plus h. 60 plus h. Definitely this will be also 60 plus h. So 60 plus h, 60 plus h, and we have an extra 60 meter here. So let us now add all these. So tan 60. Now we are taking tan 60 because angle of depression is tan 60. From this example, I have proved that angle of depression will be equal to angle of elevation. So tan 60 equal to OA by OD, right? So OA dash by OD. Sorry, it is not A, it is A dash. OA dash by OD. This is the figure. OA dash by OD. So equal to OB plus BA by OD. So tan 60 equal to root 3. Root 3 equal to 60 plus 60 plus h by root 3 h. Okay. So I have already told you that we are having a 60 meter here. So 60 plus h will be added to that. So 60 plus 60 plus h, it will be 120 plus h. 120 plus h by root 3h. So root 3 equal to 60 plus 60 plus h, that is 120 plus h by root 3h. And now we are finding out the value, substituting the value of tan 60 as root 3. Root 3 into root 3h is 3h. As you know that root 3 into root 3 is 3. So 3h equal to 120 plus h. Then 2h equal to 120. That is h will be transposed to the right hand side. So 3h minus h is 2h. 2h equal to 120. H equal to 60. So finally we have found the value of h as 60 meter. So already the man is standing 60 meter above from the ground level. Now we are extra adding a 60 meter to the cloud. So 60 meter plus 60 meter will give you the total distance of 120 meter. So 120 meter is the final height that we are getting of the cloud from the ground level to the position in which the cloud is there. So this is one of the important questions in application of trigonometry. So these are the things that we have learned now. Let me summarize the concept. First, we have learned about the concept of horizontal line, angle of elevation, and angle of depression. The three basic terminologies. Based on that, we have solved some problems. And we have also checked a particular case in which angle of depression is equal to angle of elevation. And these are the main things that we have to remember and have to apply properly to reach the concept of application of trigonometry. So these are the things that we have to keep in mind. So yes, so by there are so many other questions also, but we are only discussing up to this question. Thank you and Hari.